You're in the water loop.
Waterloop is made possible in part by grants from Spring Point Partners and the Walton Family Foundation. Hey everyone, this is Travis with Waterloop. I want to talk to you for just a minute about High Sierra shower heads. I use them in my house because they're a water-efficient fixture, but I'm a big fan for other reasons as well, including their design and construction. They're made of solid metal. So this High Sierra shower head I have in my hand right now, you can tell that it's a quality, well-made product, unlike the vast majority of shower heads, which involve a lot of plastic in their construction. And that's something we need less of, right? Less consumer products with plastic in them. The other awesome thing is their nozzle design. It's a unique patented nozzle that's not going to clog like so many other shower heads. The other thing about this nozzle is that it will work in low pressure. You'll still get a strong, powerful, but water-efficient shower. Use promo code LOOP20 for 20% off at highsierrashowerheads.com.
You're in the water loop.
Welcome to Waterloop. This is Travis. Very excited to be with Phil Bresnahan. He is an assistant professor in the Department of Earth and Ocean Sciences and also connected to the Center for Marine Science at the University of North Carolina, Wilmington, my alma mater. Phil, thanks for coming on the podcast.
Thanks for having me, Travis. It's great to be here.
Yeah, so I connected with you because I saw a few years ago, or I talked to Chad Nelson at the Surfrider Foundation, and he was talking about Smartfin technology, building a fin for surfboards and paddleboards that could gather data about the ocean. And then I saw, I don't remember when it was, that you relocated here to Wilmington, North Carolina, took a job at UNCW, and you're kind of like the leader of developing this thing. So it all has come together for me in a pretty awesome way. It's like to have you here in town and to talk to you about using sensors for studying the ocean. Let's start big picture, I guess, on that front. What are ways that sensors are used to study coastal waters and learn more about their health?
How many hours do we have here?
Hey, as long as we want.
Yeah, it's a big topic. So it depends what your particular domain expertise is. Are you interested in physical oceanography and the currents and maybe sediment transport and wave activity, coastal flooding or nuisance flooding, other things like that? My focus is more on the chemistry and what we call biogeochemistry side. So that word I know a lot of people probably haven't heard before, but it's the combination of biology, or all the living things, with geo, so the influence from land and the bottom, sediments, sand, mud, all of that, as well as, of course, the chemistry. And I'm especially interested in human impacts to coastal waters through things like the excess carbon dioxide that we put in the atmospheres that ends up dissolving in the seawater and making that water more acidic. We're also changing things like phytoplankton blooms from putting excess nutrients in the water, and that can have really interesting impacts on the surface populations of what's living in the surface. But then those phytoplankton blooms often decay in bottom waters and really draw down dissolved oxygen concentrations. And we've seen this kind of all over the country and all over the world at increasing frequency in recent years, where you actually see these massive fish kills, or actually like crab walkouts are a major issue, where the crabs are trying to come into shallower and shallower waters to find higher oxygen levels so that they can breathe through their gills. And they actually end up walking out of the water. And of course, crabs can't survive out of water for extended time periods. They need to be in the water to breathe through their gills. And so they end up dying. And so I'm interested in the chemistry side, trying to measure the nutrients, trying to measure the dissolved oxygen. And all of these things, I guess I want to say they require sensors, but truthfully, we've been making these measurements for decades using more traditional technologies like bottle samples and then running the chemical or biological analyses back in labs. But what's really exciting about the advent of sensing technologies is that we can leave them out there, and we don't have to go out every hour or every day or every week. We can just leave them out in the water and have them recording data, filling in a lot of the gaps in time and space that we weren't able to fill before we had these autonomous sensor technologies. And so, yeah, I mean, there really are quite a few different things that you can measure with a wide array of sensors. And the sensors can be extremely simple. They can just be tiny little thermometers, or they can be huge, like VW bug sized analyzers that are actually analyzing the DNA that's in the water right there, and whole range of things in between. So really cool technologies, and I'm excited to be participating in that side of coastal development, I guess.
Yeah. There's like everything's Bluetooth enabled and on Wi-Fi and connected to the internet and that type of thing. Are there sensors that are out there that you don't even have to go check and download the data that's actually, broadcasting that stuff back, and you can kind of see what's going on in more real time?
Absolutely. There are a ton that are taking advantage of every network that you mentioned. Satellite technology has been huge for oceanography because, of course, if we have a sensor in the middle of the Atlantic or Pacific Ocean, we're not going to be within range of any Bluetooth or cellular signal. But there are satellites flying overhead all the time, of course. And so what I think is one of the most exciting oceanographic sensing platforms out there is called Argo. And Argo is an international program. So countries from all over the world are contributing to this. And they're developing these robotic floats that sort of yo-yo up and down from the surface of the water column down to 2 kilometers or a bit over a mile below the surface. And as they're yo-yoing, they're collecting data on the physics, temperature, salinity, and depth. And that helps us understand the heat that's being captured by the ocean. The ocean, by the way, is capturing 90% of the excess heat that the planetary system is keeping inside it, as opposed to sending back out into outer space as a direct result of global warming and climate change. 90% of that excess heat's going into the ocean rather than just raising surface atmospheric temperatures. And so we can measure this with things like Argo, and we can see this signal in near real time because of satellite technologies. And then once you get closer to the coast, you can start tapping into cellular networks or HF radar or long-range radar or other communication technologies. But there are also huge gaps in communications right now because the ocean is opaque to certain types of communication signals. So if you have a sensor that's not actually making it up to the surface for any reason, you're just measuring ocean bottom seismometry, for instance, how a lot of earthquakes and seismic networks operate. They just have these sensors on the bottom of the ocean, and they might not necessarily want a cable that's running 6 kilometers up to the surface above wherever they are. And it can be exceedingly challenging to get that signal back. So sometimes those are still wired. Sometimes there are other vessels that will kind of fly over top and pick up the signal acoustically. And this is actually an active area of research. There's a whole sector of ocean engineering specifically focused on how do we get data back from these remote regions that don't have satellite coverage because they're deeper in the water or because we don't want the sensors to be at the surface for long periods of time for any number of reasons. A lot going on in that space.
We just are recently getting all this stuff back from Mars, right? we're getting data and weather reports back from another planet. The ocean still gives us challenges, right? That's cool. Technology is accelerating all the time, just crazy leaps and bounds. I'm wondering how that is playing out in the sensor world, how the leaps in tech and engineering are, impacting sensors and their use. I mean, I think you've kind of hit on some of it, but love to hear more.
I would say it's fair to say it's revolutionized the ocean sensor sector, the ocean sensor world. And the reason, not only have we made better sensors and better microcontrollers and better chips and so on, but we've made easier technology. And so I would say just a couple decades ago, you had to be a really diehard engineer or someone who was really interested in investing significant amounts of time into understanding circuitry and programming and how all of this stuff works together in order to make even the most basic sensor. And now all of this stuff is just openly available on any number of websites. There are some really cool projects, like Public Lab comes to mind as one, where people are building and publishing designs for water quality, air quality, soil quality sensors using off-the-shelf components that anyone can buy, not usually all that expensive, maybe couple $100, but not the hundreds of thousands of dollars sensors that a lot of academics might use. And all of the code is readily available. There are forums of folks that are interested in helping others learn how to code, how to wire things, how to solder, how to do some circuitry. And so this has really changed everyone's ability to get engaged in this type of technology development and start paying attention to their own watersheds or their own atmospheres or whatever it may be that they're interested in. And so in my case, I've really taken advantage of this and used some of these lower cost microcontrollers and learned a lot of the programming just on the fly, just teaching myself using whatever freely available web resources there are. Of course, I've been really lucky to take some great courses in this as well at the graduate and undergraduate level. But most of what I've learned that I use on a day-to-day basis is stuff that I learned just by Googling it and finding communities of active users and active practitioners, active teachers that want others to become more comfortable with the technology. It's just totally revolutionized the whole sector, I think.
Yeah, I was going to ask you a question along those lines. Is, the use of sensors really limited to universities and advanced labs and the private sector, or is there now an opportunity for environmental groups and nonprofits and others to kind of start getting involved? And so it sounds like there absolutely is a role here, cost-wise also too, cost-wise and being able to work with the tech.
Agreed, absolutely. Yeah, I think there are quite a few technologies that are even well developed enough. There's certainly a lot of technologies that are still in their infancy and need a lot more work in order to be ready for prime time and for nonprofits to be able to use those. Often in the water quality space, you'll see nonprofits that are interested in collecting water quality data so that they can use that to, go back to like a city council meeting and say, hey, we noticed that there's something exceeding a particular threshold over here. And for those data sets to be trustworthy, you certainly have to have a pretty high quality center or laboratory analysis. And there are many just openly available resources that help enable that now. There still are much more expensive options for all of that as well. But then add in some of the cutting edge artificial intelligence machine learning approaches, and folks are learning how to combine these lower cost and maybe lower accuracy technologies with the really high cost stuff, and maybe only have one of the most sophisticated things in a particular region, but you have 100 of the low cost, slightly less accurate things. And if you learn how to merge all of the data from the two in a sophisticated way, then you can actually get this very high quality kind of mesh network of sensors and data.
Wow, very, very cool. I want to pivot a little bit to maybe talking about your story and your journey and how you got into this and the way that led you to some creative development of sensors and, of course, heading towards my favorite stuff with surfing and paddling and all that kind of thing. So I mentioned you recently relocated here to Wilmington, North Carolina, but you were out in San Diego. How'd you get started on all this? What was going on out there? And then talk about some of the fun things you've developed.
Sure. So I would say that I got my start in oceanography before I even knew that it was a professional field. I grew up on the East Coast, just outside of Philadelphia, and spent all of my summers at my grandparents' house in Ocean City, New Jersey. A lot of time on a barrier island there, a lot of time in the back bays and estuaries, a lot of time on the ocean. So I was extremely lucky to be exposed to the world of ocean science, and even went on some family vacations where we went to aquariums or we went out on little research cruises and got that real world experience from a pretty young age. And I studied chemical engineering in undergrad, but wasn't really sure what I wanted to do with that. And when I heard that oceanography was like a real thing. Honestly, I didn't even know it was a career path for most of my education. I knew it. I knew in an instant that was exactly what I wanted to do. And so I was fortunate enough to get into Scripps Oceanography, part of the University of California, San Diego, did graduate school out there, and then did a quick stint in the Bay Area at a nonprofit focused on water quality sensing, and then moved back to Scripps. So I was lucky enough to get a second position there as a research engineer. And the focus of that position was developing these Smartfins, as we call them, the sensor-equipped surfboard fins that can go on surfboards, paddleboards. We've also even developed some really simple flotation devices so you can tow it behind a kayak or something like that. And through that path, I have moved from a lot of open ocean focus on things like Argo and developing new chemical sensors to monitor the carbon dioxide that the open ocean is absorbing to what the changes are that are happening along the coast. And I think that this all really connects to my childhood part of this story because I just love being on the coast. I love being in the water, experiencing it on the beaches. And maybe that sounds a little cliche. I think there are a lot of people that feel a really strong connection to the water, to the coast, to beaches, and so on. So I'm not alone there, I realize.
Yeah.
But
no, it doesn't sound cliche to me and or corny or anything. I'm on the exact same spot. So absolutely.
And another piece of that for me is that I feel like, as scientists, we've known about a lot of the changes that we're causing to the ocean for decades, or even in some cases, centuries. We've understood the relationship between CO2 and increasing temperature since, I think, 1856 is when Eunice Newton-Foote published the first paper establishing that connection. But what we haven't done as well is communicate what we know is going on out there and get more people engaged, get communities engaged in the monitoring and ultimately in the stewardship of their waters. And so I really like working in coastal waters because it's an environment that people are familiar with. A lot of people have that connection, and a lot of people want to get more engaged because it could be local to them, or it could be a place that they like going on vacation. The open ocean, I think, obviously deserves protection as well, but it's a little bit more abstract. It's far out there. And for, as long as the Industrial Revolution, or maybe even before, has been going on, we've sadly thought of the open ocean as a dumping ground for a lot of stuff because we've assumed that it's just infinitely large and can handle all of the waste but I think that the impacts that we see are a lot more tangible along the coasts, and again, people just have that connection. And so I like that there's a connection between the academic research that I do and this kind of more immediate application of the science that I can see along the coastline.
Sure. Well, I think for people watching, they can see, I think there's some of these fins in the background over your shoulder there, but I think you have one kind of at the table you could hold up for a minute and explain what's in there, what's going on.
Yeah, so this is the Smartfin. This is just a 3D printed version that we made. This is one of the earlier prototypes that I made back at Scripps with my lab mate Taylor Worth. And the Smartfin has a temperature sensor, motion, GPS. It has a wet-dry sensor, so it can turn itself on and off. It has, of course, a microcontroller and data logger, so that's the brain and the memory for the thing. So all a surfer has to do in order to use the Smartfin and collect coastal data is keep the fin charged, and it comes with a little charger that clips on there, and then go surf. It has a wet-dry sensor, so it turns itself on. It knows to record data internally during the surf session. And then as soon as the surfer gets out of the water, that wet-dry sensor says, hey, I'm out of the water, and it starts looking for a cell tower. And as long as the surfer is close enough to a cell connection at that time, it will send the data immediately to the cloud. If the surfer doesn't get back to cell coverage for an hour driving home, or maybe they're on a remote island vacation or something and they don't have it for a little bit, the data will just be stored on the fin for that time until they do get back into cell coverage, and then it will all be uploaded. So we're trying to automate as much of this process as possible because we want the surfers to focus on surfing, doing what they love doing, and have access to this cutting edge technology, but not necessarily be hampered by it or have their surfing experience held up by the use of technology. So trying to make it as seamless as possible and as enjoyable as possible. But then on the other end, once the data are all in the cloud, anyone can access these. It's a freely available website. Anyone can look at the data, whether they're a scientist or a surfer or whatever, neither. They can, see what their own individual surf session looked like in terms of ocean temperature and some other characteristics that we're working on, and keep going back to the same area time after time and see how it changes, or see regional variability by going to other places. A lot of different things that can be done with this.
That's awesome. And what about, surfing and that location in the ocean, where those waves are breaking? What's the value of gathering data in that particular zone?
Yeah, that's a really interesting question, and honestly, it's something I ask myself all the time, because I'm trying to figure out, what can we extract out of this data set? What other useful information is here? And some of the really exciting research that we've seen so far, we have a couple colleagues in the UK and other parts of Europe. Bob Bruin is one of the leaders of using the data set to understand how to calibrate satellite sensors. And so satellite sensors have been circling the globe for a long time now and making ocean measurements. And traditionally, they've done pretty well in the open ocean, where the sensor sort of knows, if you will, that it's over the ocean. But once you get close to the land, things get trickier. There are a lot of competing influences. Is the sensor looking at the coastline? Is it looking at the water? Is it looking at a nearby parcel of land? There's reflection coming in from different areas. The sand itself and the whitecaps of breaking waves will influence the readings that the sensor is getting. And so it turns out that it's particularly challenging to do some of the calibration of satellite sensors along coastlines. And sometimes that's where we really want the information, because that's where we're seeing these really fast and really large magnitude changes in things like algae and changes in sediment turbidity, water clarity, that sort of thing. Right now, the Smartfin's only doing temperature, but that one is still really useful. It's really challenging to do that along coastlines as well. So that's one area. And then it's challenging to put sensors out in breaking waves. It's just a really dynamic environment, obviously, and there aren't a lot of technologies that are well suited for it. But obviously, that's where surfers want to be. And so if we can collect data that fill in these gaps, our ultimate technology for answering every single possible question, but rather one that helps fill in gaps between other existing assets. So maybe we have sensors that are on piers or on buoys, but those are probably, a mile, 10 miles, 50 miles apart. And a surfer can, we could have 100 surfers out just at one beach, at Wrightsville Beach on a nice day. And we could see a lot of the small scale variability, which actually directly influences things like phytoplankton blooms and can be influenced by things like rip currents. And so I think there are a lot of coastal dynamics that happen at these smaller scales than we can currently measure using the far apart but perhaps more sophisticated technologies.
Yeah. Any brainstorming on future types of sensors that could be included in Smartfin?
Yeah, I was sort of hinting at a couple of those in my last answer, actually. The turbidity issue is one that I think we could really help with. I think that understanding how sediments are moving, and sediment, I always kind of laugh when I hear myself say that word, because I remember as an early stage scientist thinking like sediment, that sounds so like technical and not the way most people actually experience. It's just sand, it's mud, it's whatever, but we use this catch-all term sediment, and that one's always kind of been funny to me. But I think we can actually make some optical measurements from something like Smartfin that could monitor water clarity, which would help. If you're a diver, you'd certainly want to know what water clarity was. If you're a lifeguard, water clarity might help you understand how sand is moving off of the beach or along the beach, which could help you understand where rip currents are forming. If you're a city or county planner and you want to understand beach renourishment, you certainly need to know where the sand is moving, dredging applications, and even getting into things if you're stand-up paddling in the intracoastal or our tidal creeks. The water clarity is going to influence things like oyster health, for instance. And so I think that's one that could be really valuable. And again, not answering the question everywhere with this technology, but filling in some of those gaps, again, helping to calibrate the satellite sensors, other things like that.
You've talked about citizen science a little bit here, and surfers and paddlers, being part of this whole effort, and people involved with our environmental groups. And I just love to hear your thoughts a little bit more about why. Obviously, they're well positioned physically because they're out there in the water. But what else about them, makes them such a good fit for helping to contribute to coastal science?
Well, other than just being in the water and being able to collect data there, they're the folks who are generally the most invested in coastal water quality. They're the ones who need ocean water quality to be of the highest possible standard. You're not going to put your head in the water if you know that there's a ton of bacteria there, or viral particles, or even if it's just really murky and sediment rich, or algae blooms, any of these things. And I think that by working with communities of really engaged folks who know that they care about these things, but don't necessarily know where to get started or how to contribute, we think that Smartfin and some other similar kind of citizen or community science initiatives can provide a bit of an on-ramp so that folks can get more engaged in the monitoring of their own water bodies and the monitoring of their playgrounds, really. And then learn a little bit through that. Maybe Smartfin, because the technology is all automated, is an easy first step, but then maybe they learn something, they decide they want to ask a question that has them digging deeper into a particular subtopic, or maybe making other measurements with other sensors, or maybe going to town halls or city council meetings to say, this is what they learned by participating in this program. So we think that Smartfin is a really great way to get engaged. It's not the end goal necessarily. It's just kind of a stepping stone on the way, both in terms of filling in these gaps in data, but then also getting more people engaged. And I think it's, as we talked about earlier, technology has historically been really hard to access by many communities, by many people other than the top academics at the top institutions or top government research agencies. And I think there's real value in making these technologies more available. The buzz term is democratizing technology. And I don't know if we're quite there yet. A couple $100 is not free, but we're getting to the point where more people can access these technologies, more people can monitor the water, air, soil quality, or whatever it may be of their own playgrounds or of their own backyards, literally. And I think that's a really valuable thing.
Yeah. Well, I've said it off air. I've got to do it on the record now that I'm really raising my hand to try to be one of the first people to get one of those Smartfins when they're ready to go out. I want to be part of that science, and I just think that's so awesome. Glad to have you here in town. COVID's hopefully wrapping up here, and look forward to getting out on the water with you at some point. And I can learn a lot tagging along with an oceanographer, so be cool. But Phil, I appreciate the time and all the info, really a lot.
Thank you, Travis. Yeah, I look forward to getting out on the water with you as well.
Waterloop.
Thanks, everyone, for listening to today's episode. A special thanks to Waterloop supporters, Spring Point Partners, and the Walton Family Foundation. The Waterloop podcast is sponsored by High Sierra Showerheads, the smart, stylish way to save energy, water, and money while enjoying a powerful shower. Use promo code LOOP20 for 20% off at highsierrashowerheads.com. If you like Waterloop, please subscribe to the YouTube channel or your favorite podcast platform. Follow us on social media and visit waterloop.org to sign up for updates.